Hello. Welcome to my series of updating old projects to solve modern problems. I have created a few videos before. It's about definition of the problem, what kind of problem I have, why it needs to be to rework old project, which is very similar. Maybe it might share some code. And there was explanation about why it's pipelines. So yesterday on previous stream I have stopped and architecture definition, and it was about what are we going to pick, how we are going to organize those things, and what are bottlenecks of solution I would like to implement. So let's proceed about. Yesterday we had a situation when it was about database, storage, and some previous things. For example, why do we need a shared storage? It's necessary to share results of each individual pipeline with other pipeline. So it's, let me increase this font size maybe. I think it's fine, but okay. Yeah, that one's better. It's for pipeline. So we have shared storage. Obviously, there are a few things which are also necessary, since it's, let's say, a thing which is not very critical because it uses nearly everywhere open source solutions. There is nothing proprietary. I'm going to run it in my local Wi-Fi network. There is no need to hide it behind virtual private networks. There is no need to introduce certificates, but security concerns will definitely overview it later, because as a schema which I decided while today, it's necessary to think about security. So right now, we will ignore this item. Say yes to shared storage, no to virtual private network. About database, since our network communication will be done in, let me move this thing here. So a few important notices. There are two options. Network communication. I remember how it was done, but I had to figure it out again. Multicast DNS, service discovery. And there is another more classical way. It's so-called service registry. At every job I used to have, there was a small problem with understanding why do we need service discovery, because we have config where we pass service name. For example, if we need to resize image that would have some service name. Let's call it resize img local. There could be another service, for example, like this. It could compress video, resize video, that's better. And the classic schema behind that thing, this hostname is served by Nginx. Let's do it here. Each service hostname with load balancing, possibly some custom authentication and other security measures. Served by Nginx, which provides so that was important. In here, in my home setup, I don't need Nginx because multicast DNS. Now let's remove this item. It's pretty straightforward. It's when your service advertises itself in local network, just like hello, I am image resize, I'm here. Let me show you the terminal I have. Yeah, you can see it. So left top window in here, it's this pen. It's in one of my MacBooks. It's a remote server. It's on local Wi-Fi. So what can I say? Let me increase the size. Yeah. So DNS service discovery /r, and let's say this worker can handle HTTP requests to outside. Maybe it has some features such as access to OpenAI credentials, because as it is some HTTP records should not have some authorization, but it's not good example. Let me do another example. Not this one. It's block video resizer, image resizer. And in this case, we can pass some parameters to DNS. For example, load average or current load, if it's available for new operations, and some features such, let's say, processing in GPU or processing in CPU. If it's old laptop, its GPU might have problems. In this case, image, no alpha channels. So this service right now, it has advertised itself. Now the pan below, it's my Windows PC, the one I'm streaming from. So what do? We simply say, hello DNSSD, do you have anything for us? There was /b. Yes, broadcast, browse for services. Yes, it's good. So we write /b, and it will monitor our current situation. Let's say, how can I extend this window? Yeah. What if in here, then SSD, I have another block. According to this, it will be text to speech to video, TTS generation. That would be better. it works on another port, maybe, yes, another port, and it's OpenAI. So I have executed a second service. It has advertised itself, which means in our current service discovery, DNS service discovery, we can see it. But what if our service goes down for some reason? Let's assume power off. Let's simulate this situation. I will simply kill this process. It should yes, here it marked as removed. And if we start it again, it should be marked as added. That's right. So let's check a few things. What if we have another service, another worker here, text-to-speech generation, which also works on the same port, but it has different load, and it's available with feature Windows TTS. So Windows has its own text-to-speech engine. So let's assume I have some PC which has this feature enabled. It should be here number 3. What's that? Maybe it's about port. Yeah, it's about port. So, as for this, any client might request an address of that worker. Assume it was -L, I think. Yes. Name type domain, look for a service instance. HTTP, TCP, well, let's say local. No, it should be, how was it named? Let me, block image resize. No. Okay, let's browse. HTTP, TCP, block image resize, domain local. And that flag was telling me domain local. It should be in the end. Come on. I had a history. Let me check. Grep slash tel. Oh, of course, there is no grep in here. It's Windows terminal. Okay, time to allow share Firefox. And then sd/egg browse request address service. There was something yes, it should be. yeah, registering services via, yeah, that stuff. Let's touch. Where is it? Yeah. So I was wondering if there is some. There was a solution. I'm wondering. The problem is quite interesting because then assist the /b. So it's browse. What if I have another service but on same port? Why it's not added to here? Added, remove. Maybe because it's coming from the same machine, the same port. So if I move it to another port, the generation 2 is the same port. Yes, it's added. We need to add new name if the same port is present. That's logically correct. So as for that, /l, what were the flags? Name. It was image resize block. Resize, then type http TCP can be reached. Yes. There was another flag why it's not domain. Is it optional? Local. Wait. Yes, it yields the same, so there is no need of dot. That's good. So what happens? What if I need, and this is the /b, I have two text-to-speech generations. So I need to visit block generation can be reached. Yes, that's correct. And now if I stop it and name it the same text-to-speech generation, the same port, it should not be advertised there. Yes, because it's the same port, the same service, no need never complicate. And what if it runs on different port? It should be here as well. Yes, it's here. It simply gets new name, but I didn't name it text-to-speech 2, which means I can check TTS generation and it should yield me two addresses. It did not. That's a problem I would like to find, but let's go back to our document. So we had an issue, at least I had, why I picked DNS service discovery on top of a regular service registry. There is a problem which I see as it's a local thing. I don't need Nginx in there. All I need is a few services which can get its own device. For example, I have a laptop which is 10 years old. It can do a few things. So let's use it as that, which means I would like to proceed with this schema, but this schema would have one problem. It will have problems. Security. Nginx provides it's quite simple. It has built authorizations such as basic, certificate checks, etc. But in this particular case, each worker, each service would need some library to be implemented as code. So how to solve it? Security. By default, there is no security. Or there is better explanation. It's worker the responsibility for security checks, etc. It's on worker behalf. So worker must have those checks. That means each worker will have to include some library. Let's say this, each worker will include some library. Yes, authentication, authorization. Yes, that's most important problem, because if you have unexpected guest with flash drive, it might end that its flash drive is mini PC, which will advertise itself as a service. So this is first problem. And the second problem, it was load balancing. So let me try to do it again in terminal. Here it is. In here I said it's text-to-speech generation which works on that port. Nice. And here I said it's text-to-speech generation which works in another port. Good. So in our, let's say, client, check it, and there is text-to-speech generation. I believe there is better way to make requests. It was not /l, it was, let me find it, there was partial match /name type domain. So I can test registration multiple. So I was wondering. It yields me one first, which is 10%. Yes. What if I mark it as no? Is there any magic about it? I don't believe there is magic because it's text records, there's nothing. But yes, there is no magic, that's good. But what we can do, it won't work. We can browse it. Is it correct? Type and domain. There is aha, that's correct. So we can browse it and then we can grep it. Of course, Windows has no grep. Sorry. So then we can grep those things and find out which of them is available. Which means generation. How it yields those data. So we can grab it after. So we do /b, then we do /l, but there are client libraries. Let me show it in terminal, sorry. I remember there were a few client multicast DNS. Is it going? Yes, it's going. So what if we need my website, then register this new service that can create a responder. Yes, there are client libraries for this solution, which means let's go. Somehow my webcam, let's move it here. Yeah, now it's better. So we have client libraries which definitely can also take care of about load balancing. We have load balancing based on that sidecar inside of that worker, but it's also worker must have load balancing report included to library. That means this load balancing it's about a report and a request included. So it will take care about respect load equals some percent and available equals yes or no. In this case, security will think about it a bit later. There are a few ways how to do it. One of those ways is to include some mutual TLS when both services can exchange keys, but there is another security issue. Those certificates must be rotated. So if we included certificate in worker 1 and worker 2, there will be consequences. So that means we'll need to create some certificate authority. Maybe it will take a while, a few more streams, but for now let's trust because it's in the Wi-Fi network which no one cares about. Yes, it's bad, but I have what I have. Should respect parameters about load. It will be load balancing, and it will solve the problem with Nginx. What else? I think that's all. By the way, there is also another security issue. How will worker will understand that another worker is free to connect? Oh, by the way, also Nginx used to solve reconnection. It's called, I think it's reliability, load balance, reliability, and security load balance. It's inside of reliability. But we can talk about it. So in this case, it's another issue. How to process things if one worker goes down. So processing worker outages, network issues. let's call it simple. How to do send issues. For example, we can include another library. The pattern was named circuit breaker. I used it in my most recent working place. Let me show how. I think you can find it. A very good image about it. It's not opening. Let me increase text. So the idea is quite straightforward. We make request to some service. That service might have outage or it's shutting down. So there is graceful timeout or graceful shutdown, which says for every income request, it responds with, sorry, I'm done, I'm going to shut down. So circuit breaker would try to repeat in some timeout, it depends. Continuous timeout, yes, there is number of requests to check. So it will try to repeat that request again. There are thresholds as, yes, such as timeouts, back-off strategy, for example. Retry in 5 seconds plus random, yes, but random is incremental retry. Yes, this is what I used to use in most retries. It's exponential back-off, like 1, 2, 14, whatever seconds. That is what we'll need to include in our reliability to each worker. So let's include it to here. Circuit breaker for reliability. With that, we don't need Nginx to load balance each of our services, I mean workers. So service registry, it was another bottleneck. So we have database, it also might be a service registry, but if database for some reason goes down, whole system will halt. It will simply say, sorry, no database, there is no workers discovery. Let's do it in pros and cons. But you might have noticed that I'm going to try this one. It's DNS service discovery. So these are problems we'll need to solve. In this case, there are only a few problems we need to solve. First problem, it would be, let me do another thing. It's a variety of configs. I mean, Nginx configs. We'll have to, how to say it, store them somewhere. We'll have to retrieve them to the machine which serves that host name, which works as a load balancer. So in this case, we have outcome load balancer, it's proxy. That would be correct. proxy, and let's move its name. Oops. Oh, no. That proxy for. Come on. Join audio. Merge. For example, it's to join to video, merge to videos. So in this case, if Nginx, yes, that's service discovery based on database. So if database goes down, everything is dead. Multicast DNS, it's multicast inside network. I don't think there is a problem with bottlenecks in that place, but there are definitely some problems, but not like this. APIs can also advertise themselves into that multicast as easy as, for example, here, let's make it not blocker, but API pipelines, API available without anything. So in this case, there is API, so we might request it, and we don't need Nginx because of load, the nature of load to this project. This API, its only job would be a pass one request to pipeline, to pass one request to any of those workers. So that request might look like, let me write it here, the job of API is to pass one request to worker. Let's make it as some abstract JSON, but it's definitely not JSON because it might pass anything else. So pipeline, it's an object which contains a few entities, just like we used to read. It might, where is it? Yeah, pipeline. It should be an array because the map is unordered, but order in this particular case is important. Block was it named HTTP request? Yeah, HTTP request. Some data. Another block. It might be another HTTP request. Oh, by the way, it won't be just data, it will be input, some data, and output. In this particular case, we don't need it, but it is important to mention that this pipeline will be described by API itself. So workers, they don't understand anything. They only know about themselves, what they can do, and nothing else. They also know about storage. So in this case, when worker 1, which name is HTTP request, receives this request from API, it looks at first part. It checks that yes, it's my name. I was addressed correctly by API, and there is some data it must work. What's important, it's that each worker must pass this request to another worker. So initially, it will look like that let's assume we have one worker and one operation, which is HTTP request, block request name, some title of this block. Let's call it fetch text from OpenAI. It will be quite simple. Get text from OpenAI. There are data such as headers, for example, authorization token, which that's not good, but it's what we have. And then it has some input, such as text, baby prompt, which is what do you think about ABC? So when a worker meets it, it understands that. Let's also add description. That's for some debugging purposes. By the way, title, description, and some structure, it comes from API. There is no need to... So API has its own storage. Let's make it... Where should API store pipeline data? We have file storage, which should be available for all of these things. Shared storage for API, and I could have introduced database, but it's already too much. V6, let's say WN. That will be correct. So when worker gets it, it should simply return result and store it in shared storage. In this particular case, what should it yield? It should yield its own result. Maybe it would be not get text, but get file text to speech. Let's do that. From OpenAI, there's description, headers, input. It won't be prompt, it will be text. So in this particular case, the output workers. First of all, it would be the file with text to speech, obviously, and yeah, first of all, JSON with a result of proxy pipeline. So that JSON would look like, I think, the same. Just input, let's call it output. And it might be something like better FTP. something like this. But I remember there was another thing: download image, generate image. Where is the file itself? Step 1, step 2, step. Yes, message Telegram here. MP3. That's correct. Here, MP3. File with the test. So there will be JSON with result. There will be output as well as input. Maybe we should call it different. Don't move it to data. Maybe. I don't like it, but result. It's possible that error would be a part. Error warning. It's a result, but I don't like it. Because it will yield another. That's already a very bad interface, like no. But it's about architecture. Let's skip this thing. So those workers and APIs should work with through shared storage. They should not have some database, because if we introduce database, we'll have to introduce extra dependencies as well as definitely ORM. ORM, I'm sorry, but I don't like it. So about configs. In this particular case, problems. Let's go with cons. Was that mDNS? It's 3, that's 4. Service discovery, it's cons. And pros. Load balancing. Security. Reliability. Some sort of reliability, because if some node goes offline, Nginx removes it from upstream configuration, but I wouldn't call it 100% reliability. It's part of load balancing. Security, it certificates. In here, it's important that part of load balancing there are timeouts, extra headers. What else does it have? I don't remember for sure, but there were such things. How was it called? It could send metrics from Nginx without making some metrics. It's built into Nginx, so we can find records per second without any extra tools in our solution. There must be another library. Metrics and logs. Include some library. Because those logging must be done in some very unique format. Those metrics, where will we send it? It's definitely Grafana. because I want to understand that for some reason my worker number 6 goes down. It has no disk, for example. It's a problem. But there is good things in mDNS. No single point of failure. If APIs go down for any reason, I will get a report, but there is another API, another API. There is no Nginx load balancing them. It's, I think, good, but still we can discuss it in comments. It's easier advertisement in local network, in that network. Features. It should be a part of easy advertisement. It's called text and records. Text and record, advertisement. What else? Independence. There is no pipeline state except shared storage. So if for some reason shared storage goes down, the worker which, yes, there is shared storage, which is, yes, for sure, but unlike database, which can have, I remember in Postgres, it's 2 items. Let me share screen. Postgres. There are patroni and another, how was it called? Packet bouncer. So patroni. Yeah, patroni is template for high availability Postgres solutions. This the keeper in the console Kubernetes. That's good. But at my last job there was PG bouncer. Let's see some description. Oh, wait, there is no information. Documentation. FAQ. Is a Postgres server, so simply point your client to the PG bouncer port. But what's behind? I remember it was just 2 instances. Let me check. DNS round robin. So, yes, there are problems I used to have with, I think, Patroni sessions. So, when you use a session with cursor, when you need to fetch quite big dataset, if there was switch, I don't know, maybe it's DNS round robin, whatever. If you have switch from that server A to server B, your big data set iteration, it will be simply reset. You will get a doubled number of page 1 duplicates. Just, yeah, you will have duplicates if you use sessions with a load balancer inside of Postgres. That was quite big issue back in the day, and it took some time to investigate. That's the reason why I don't like to introduce databases to local projects which don't need database. In case of shared storage, even if one of disks in NAS goes down, you can simply go to repair it, maybe replace it. But it's cheaper, easier, and you have no problems. No single point of failure is advertisement. But let's make it a con. Shared storage must be. I'm sorry, but it's necessary. no need of no need of nginx config. That's also a good thing, because if you have n number of workers which resize video, there is n IPs which must be listed in nginx load balancer, because load balancer requires IP. In this case, it just says, hello, my IP is, let me show you, terminal. In this case, it simply says, hello, I'm here, you can request me, and that's how this service is get its operations, I think. And obviously it has live removal from DNS records. Like here, it's RAM, and if I start this API, it will be added. Yes, nice. So this is how I evaluated that our architecture would be based on DNS and a few things such as API and workers which do not know anything except what it must do. We'll define this, I wouldn't call it protocol, but it will define communication standards and interfaces between workers next stream, because this stream should end in 4 minutes. Service registry for my particular project is, it could be easier, but I don't like it, to be honest. So we can remove it. And our architecture, network communication. Let's preview this in Markdown. Open preview to the site. Yeah, the table is already... let's make it like this. Okay, I will need to introduce some UML. I think it was called PUML. Extensions. Why it's not here? What is it? Because these tables are definitely not fine. I can make it in draft, but for sure we'll need something like that. How was it called? TypeScript, UML? No. Okay, we'll do it next time. Because our current thing, it's shared storage, multicast DNS, dedicated. I wouldn't call it dedicated, but it's workers which use this multicast DNS. Used by workers and API, yes. That's all. That will be our architecture, what we need. There won't be any security in this step. We'll definitely introduce security next. Though security will be something like this, mutual TLS, or credentials based on Vault, for example. Yes. So that's what I think about architecture section. Let's yes, that's all for now. it should be very easy at first glance. So next time, it will be in Wednesday, in a few days, I would like to talk about stack. So for now, just a small spoiler, what I would like to have, it's one binary for each of those things. For example, API and workers. For API, there should be definitely web server. Definitely it should have some config which is evaluated dynamically, but have access to shared storage to show you something. So front end, it will be React TypeScript because it's type safety and easy. Backend. This one I would like to do. I would like to do nothing because the best API is static page. Before that, let's check one more thing. I'll share Firefox. So I want to check if TypeScript has mDNS libraries. mDNS, let me create this. Package description, multicast DNS server discovery. Wow, it has it. To Node.js, which means create advertisement. But what if I don't want advertisement? I want to discover documentation, user guide. It's missing. Okay, where is that source? Years ago. Okay, no problems. User guide. It's missing. Flutter donation also missing. Installation. We had daemon for DNS as there. On Windows, yes, it is correct. Okay, let's try to install it in local machine. I have a terminal here. Will it work? There are problems because it's root, I think, which I'm missing. Entering directory, leaving directory. It was okay. Yes, I think it must be done from -G. Will it work? Come on. What error was there? So DNS is the hash. We don't have library. Let's check. What? We are in VSL. Wait. There was description that in Linux we should use. So we need some. Yes. Terminal. Let's hide it. So front end. React TypeScript with some library. There are a few libraries. Needs a system for the communication. Multicast mDNS. That would resolve a lot of things, such as what if I need Python backend? It would be Django with some static page, and it won't be TypeScript. It will be horrible. So in this case, we will have static page. We'll do it later. There will be one static page, nothing else. As for the worker, I would like to pick a Golang. And the whole worker, yeah, Golang. There is no backend or frontend, it's just Golang. The reason I want to have one binary for every type of worker. Justification is quite straightforward. One binary for all workers. I think you noted one thing in the way I managed to advertise this service. There are such things as features, which means I can, in Golang itself, check if some device have GPU, if it has CPUs, number of cores, etc. And I can include it into features. After that, it is possible that we won't need service name itself. We'll browse features, but it will be definitely not today. That's the reason I want to have one binary, which will be maybe Docker containers, maybe in Android phone itself. The binary for workers must be able to detect features of device running on. That's important. And by the way, let me save the thing. About info about advertisement, service advertisement, and service discovery, because eventually I might forget about it. That is it. So, terminal, I will hide it. Yeah, good. So, what have we done today? We have defined solution for our architecture, which is quite small because it's home project. We don't need crazy security thing. We don't process some secret data. It's publicly available data. We defined architecture, evaluated pros and cons of two different options, such as multicast DNS and the service registry as a standalone solution. I explained why I don't like database in this case. And we have spoiled some tech stack picks. Next stream will be in Wednesday, as the Twitch schedule has. In there, I will explain a few things. I will also try to make draft of UI, which let's say, which will have some access to shared storage. Maybe it should be FTP, because FTP, unlike other stuff, can provide some level of standardization. Maybe it should be Samba, Windows shared folder. So that's my plan for next stream. Thank you for watching. Please like, subscribe, and share. See you in next Wednesday. Bye.